Alright, let's take a look at the precise failure here with the second gear synchro resulting in our crunchy shifting on this rod change box out of our 67. We can see right here, here's second gear, and this is the synchro ring, the synchronizer ring, the balk ring, it's called a number of things. We can see that there's no gap here. The job this thing does, when this gear goes to shift forward, it engages this synchro ring onto this cone, onto this hub of the gear. And there's usually a gap there so that as you start to shift, this ring does the job of synchronizing the speed of these two, so that that collar slides right over these little teeth. Over here we can see this is also in fourth gear. I've actually got this gearbox locked in two gears for the purposes of undoing the big nut here, which we just did with our extension jig, our metal bar. And then we're going to take off the front nut also on the input gear. But you can see the difference here. This synchro, this ring is obviously all the way flat to this front surface, whereas there's supposed to be a gap here. When you push this one forward, you can see there's a small gap here.
Kind of a spring too.
No, it's just sitting on a cone. There's no spring or anything. This just is engaged on the shaft here, so it's always turning. And when you put pressure on it, it puts load on the gear here to bring the two into the same speed. It synchronizes their speed so that this collar can slide right over these little teeth. Now when it's flat like this, I'm going to show what happens. I've got another set of gears here. We'll show a sampler, but I'm going to hand the camera over, and then I'll be able to use both hands over here. And that would be like. Alright, so we've got here, this is the first gear, and we can see here's how the synchro is supposed to be. It comes up, you've got a gap here, and the specification is somewhere, but 10, 20 thousandths, something like that. 30 thousandths is about where they start out new on most of these. But when there's room here, then when this goes forward, you can see it rides up on this cone, and it brings this gear into speed really quickly, so that these teeth, there's only three positions where it goes, that these teeth, when they're going the same speed, slide in real nice. That's a nice quiet shift. Now, a worn out synchro, no gap at all. So this thing just basically freewheels on here. There is no contact along this cone or this inside edge. You can see how these are really kind of worn flat. But that causes it to not have enough load to bring the gear up to the right speed. So what you have is a shift, and we'll exaggerate here. We won't be able to duplicate it, of course, because we're not spinning it with an engine. But you get the kind of a shift that does a hard sort of a grind because the gears are not going the same speed. Now this gear physically has to grab these teeth as they're spinning different speeds. So if I can duplicate kind of a hard, that's what you get when it's a crunch. Crunch shift is because these teeth are just having to physically crash together rather than this guy doing the job of making these go the same speed before they engage. If they're going the same speed, you can see it's a very nice smooth click. And if they're not, that's a hard crunch into gear because now it's got to physically spin it. So we're going to make this work the right way so that it shifts nice and quiet, and yet with our powerful engine we can still kind of bang the gears and do what we like to do when we have a powerful car. So we'll make it work better. That's our plan.